There's an opportunity here for a company to make really, really, really big neural networks that are very good at language and provide companies access to them.
And welcome everyone to SlatorPod. Today's a very special episode on a complex topic. Joining us today is Nick Frosst. So Nick's the co-founder of Cohere AI, a startup that provides easy-to-use NLP products to developers and businesses. Cohere also raised a 170 million round, or a couple of rounds this year. So hi, Nick.
Hey, how's it going?
Very well. Where does this podcast find you today? What country? What city? What part of the world?
I'm in Toronto, Ontario, Canada, in an apartment that I moved into 2 days ago. So it's still setting things up.
Housewarming podcast. All right. So, just to start off, for our listeners who are, mostly from the translation, localization, language services industry, just give us kind of the elevator pitch for Cohere so we can get a better understanding of what you and the company do.
For sure. Cohere is a natural language processing company. So we sell an API that allows developers to solve any language problem they might have. So if they need content generation, or they need semantic search, or they need entity extraction or classification, those are all things that our API can do. And it does all of those powered with large neural networks and like state-of-the-art language AI.
Got it. And so tell us a bit more about your professional background. I mean, you were with, I think, Google prior to Cohere, and kind of what drew you into the NLP space? Because, I mean, of course, there's a lot of other avenues open when you're with a kind of tech giant like Google.
Yeah, for sure. So I was at Google for a while. I worked in the Toronto research brain office, where I worked with Geoff Hinton on things like vision and adversarial examples and capsule networks. So stuff that was pretty unrelated to language. Um, but one of the interesting things about AI these days is that it turns out it's the same strategy that is the best at vision, as is the best at language, as is now the best at almost every domain. Um, so neural networks can be used for all of these things. And I was researching neural networks and then got very excited about neural networks application to language. And so made the switch to found Cohere with Aidan and Aidan.
So that was in 2019, right? When you guys started the company.
Yeah, I joined in January of 2020.
Got it. So can you tell us a bit of the origin story behind founding with Aidan Gomez and Ivan Chang?
Ivan Zhang.
Same. Okay.
Yeah. So Aidan is one of the co-authors of a paper called "Attention is All You Need." So for your audience who are not familiar with neural networks are like a form of machine learning, and transformers are a type of neural network. And it was this paper in 2017 called "Attention is All You Need" that introduced this new type of neural network. A few years later, other researchers showed that that type of neural network could be scaled up to be a really huge neural network. And when they did that, they got really, really good performance on language. So that was very motivational and like inspirational for us. And Aidan in particular, after seeing this, came to the conclusion that there's an opportunity here for a company to make really, really, really big neural networks that are very good at language and provide companies access to them. So sometimes we think about our technology like a power plant, right? Like, you're in a house, I'm in a house, we're both using electricity, but neither of us have built our own generators, right? We're just plugged up to a centralized generator and we're paying for our electric usage. That's what Cohere is trying to be for natural language. We upfront the cost of creating these massive transformer neural networks, and then we hook up companies to them and they pay for usage. So that's a really that's a kind of win-win situation for everybody. Companies get access to a thing that they couldn't themselves build, and we get to build a company that is adding value in some way.
Yeah, that paper, I remember the title. That was one of the foundational papers, or the foundational papers, right, in that space. And a lot has happened since, yeah.
A lot has happened since, yeah. But that original paper is what introduced the idea.
Got it. So you guys started like in late 2019, early 2020. So what was kind of the trajectory early on? I guess it was in stealth for a while, and then you raised a seed and a Series A.
Yeah, so we started with a seed from Radical, which is a Toronto firm that specializes in AI. And then we did a series B, a series A with Index, and then a series B with Tiger Global.
All right, let's talk about large language models, which is something that we've been struggling to cover at Slator a little bit over the past year because it's become such a big part of everything, not just language, of course, but like also vision and other applications. So can you just break down the concept of large language models for our listeners? Probably you already kind of alluded to some parts of it, just kind of for the non-ML expert but interested lay audience.
Yeah, for sure. So people have been trying to get computers to understand language for a very long time, right? That's been since computers were invented, that's been one of the very cool, promising things we hoped that they would one day do. And for a long time, people tried to get computers to understand language by building in like rules, like hard coding rules about the way we thought language worked, or particularly the way we thought English worked. So we would do things like say that, write a rule that says every sentence has a subject and a verb and an object. And we would write parsers that would try to look at a sentence and figure out what word was what. Was this a noun or a particle or try to figure out the grammatical structure of that sentence. And then it would try to infer the meaning based on dictionaries that described words and the sentence that was constructed. We tried that for a really long time, and it didn't ever really work. You could never really get a computer to respond sensibly or take an action based on the sentence that was given to it. And the reason for that is that language is very messy. Even as I'm talking to you now, I'm like starting and stopping in the middle of sentences. I'm adding on conjunctions. I'm giving you run-on sentences forever. Like I don't even finish half of the sentence I open with you, and yet you're able to understand. And so that kind of like structured rule-based approach looks really good on paper, but in practice is really complicated. So in the past handful of years, there's been this other thing that was going on, and it first showed promise in vision, and that is machine learning. So instead of trying to hard code rules, we're just going to say we're going to set up a system where we'll give the computer a bunch of examples of what it should do, and it will learn how to do the task we're doing. So that's what machine learning is. Neural networks are a particular type of are a particular type of machine learning. And transformers, which were introduced by that seminal paper, they're just a particular type of neural network. Now, the reason they work so well is for a bunch of reasons. They have a particularly good mechanism for looking at sequences, and that is very good for text. They're also very easy to scale. They're also very easy to make very big versions of. And it turns out when you make a really big version of it, you get very good performance. So now, instead of teaching the model, like trying to teach a computer by writing rules, we just show it as much text as we can possibly get. We train this system where we show it some text and try to get it to predict the next text. And in so doing, we end up with a thing that can take in the first half of a sentence and write a second half, or it can take in text and do entity extraction, or it can take in text and write summaries and things like that, or even translation now, because those are all just text problems and they can be handled by the system that understands text.
I think translation might have been one of the first out of the gate, because we being like the language industry, the translation industry, was very early, like in 2017, it was obvious that this was going to change the way the industry works, right? And some of the products that I'm seeing now are a lot later, right? I mean, you guys are offering, I think you have 3 on your website: classify, generate, and embed, which maybe you can talk a bit about that, but also I think they're a little later than just a straightforward machine translation use case for these models, right? But yeah, back to you, the products you offer. I think just from your website, there's 3, right? Classify, generate, and embed.
We offer 3 endpoints. These are an endpoint is we have a function that we're running. We run it on our server. If your computer makes a request to our server, we can send back these 3 things. So the generate, it takes in text and then writes more text. That's what it does. It turns out you could use that for all kinds of things. You can use that to get a summary. You can use that to do to write blog post content or something. You can use that to do entity extraction. And the way you do that is through prompt engineering. So you like you're clever about the text you give the model, and then the model will give you back something sensible. So if I want a summary of a paragraph, what I can do is I can give the model the paragraph and then write TLDR colon, and then the model will know like, oh, hey, I need to write a summary here. And you can do similar things for classification and stuff like that. We also offer this classify, and that's based on embeddings actually, simply because now it performs better. But that's where you can give text and a handful of examples of how you would like things classified and then get a classification back. And finally, we do embeddings, and embeddings is the most like mathy, I guess. I think it's used by people who are mostly doing more complicated things with this type of technology. But an embedding is just a vector, and a vector is just a list of numbers. So you give it some text and you get a list of numbers back. It turns out you can use those list of numbers for semantic search or for clustering, and you can do that by measuring the distance within that vector space. Effectively, it just means you put in text, you get a list of numbers, and now you can do arithmetic on those list of numbers for various purposes.
That sounds a lot less consumery than the generate one, which is basically, hey, you give it a prompt and it'll write a blog post for you.
Yeah, so I think like that the embedding stuff is super useful, and the embedding stuff turns out to be like there's lots of we're pushing the boundaries in embedding a lot these days. We're like gearing up to have some cool things coming out, and a lot of that's because I think the embeddings are definitely more. You need to be more of a technical expert to make use of them, but if you know what you're doing, you can build some really cool stuff with it.
Maybe just dwell on that AI writer for a bit, because there's been a bunch of products that have come out recently. Like, do you see this as a vast field and the more players, the merrier, or is it kind of a bit of a land grab at the moment?
No, I mean I think that the space is big. There's a lot of people in this industry. There's a lot of people trying to provide natural language solutions to people. That's because it's mostly a good idea. I think most people mostly agree, like, yeah, cool. No, transformers are cool and they're difficult to make, and so it's useful to create one and give people access to it. I think it's a pretty big field. Like to me, it's very odd that we spend our whole lives, learning how to communicate via language, and then when we sit in front of a computer, we really don't use that skill, and we have to learn how to communicate with the computer. Like that's very odd to me. It really should be that you sit down in front of your computer and you communicate with it the way you learn how to communicate with people. So I think there's a lot to go. There's a lot of ground to dig. There's a lot to build.
That kind of alludes to the you removing complexity. But when you're mentioning on your website, like you say the default Cohere wants to become the default NLP toolkit for developers. So can you just kind of specify a little bit what kind of developer and like what's the level of sophistication these developers need to build, right?
In the long term, I would love for any developer in the world to sit down and think, wow, I have this kind of language problem, and to think that Cohere could be the language solution. That's the goal. Like I really want to build something that's super easy to use, that anybody could come to and solve whatever language problem they have. And so that like if you're building any app, you think to yourself, yeah, sure, why don't I use language in this way? Why wouldn't I use language as the interface? Because it should be so easy to integrate that you wouldn't need any expertise at all. I don't think we're quite there yet. I think right now we're getting there. Like Codoc, like our classification endpoint is very easy to use. You don't need to understand how classification works. You don't need to understand what technology is backing it. You can just come and give it a few examples and get some out. You can do the same with generate to do things like entity extraction and to do things like summarization. But you need to understand how prompt engineering works, and that's a barrier. And the embeddings are useful, but they're very useful, but definitely requires more expertise. So I think right now, like the people who are making the most use out of our technology and who are building the coolest stuff, I've seen some like totally novice people build cool stuff with it who had no exposure to machine learning or NLP or anything, but get onboarded and build stuff. I've seen more people who have some experience working on it and then building cool stuff. But as time goes on, like we're pushing that barrier as low as possible. The goal is to make it so that anybody could jump on and build something cool.
And like within the enterprise, would that be like quite large enterprises with like somewhat sophisticated tech teams that have a couple of people that are super interested in this, or is it quite broad in terms of the type of companies that you're targeting?
It's quite broad. Yeah, I've seen people do very cool stuff with it at large companies, and people who are, in high school who have never worked on this stuff before, working like on their own for fun, build cool stuff with it. So it's very broad.
How does multilingual kind of figure in your offering? Like, how do you handle different languages? Like, do prompts, like, could I put in a German prompt and get something out of it, or is it restricted somewhat?
So right now we like grade and rate our model on English. Like we measure our performances, our generative model on English. Um, and the reason we do that is that we mostly speak English, and the data we got was mostly English, and the eval sets that are out there are English. But as our company has grown, it's very obvious that there's a huge space there for multilingual. In particular, multilingual embeddings are something that we think are really promising. It would be very cool if you could embed a sentence in one language and find similar sentences in another language, or embed a whole document and see where, regardless of language, similar things have been discussed. So there'll be some cool things coming out from us in the future in that regard. But yeah, multilingual is very exciting.
Yeah, it's definitely for our industry as well, right? That whose job it is to convert that. Maybe a little bit on a tangent, but like recently there's been a lot of noise on Twitter, and I saw all these images about like Dall-E and Stable Diffusion, and then recently like Whisper from OpenAI. Like, are you also sensing there's a bit of a, I mean, I hate to use the word, but breakthroughs in terms of productization coming through right now, or do you feel it's just kind of an incremental step?
No, I think all those things are super cool. Yeah, no, I think yeah, I wouldn't hesitate to use the word breakthrough for Stable Diffusion and Dall-E. Like I think those are really, really cool applications. There's some really smart decisions that went into making them. The diffusion thing was really cool. And it's obviously captured the attention of tons of people because it's very fun to get AI to generate something like that. So it's just really fun for people. I think there'll be a while before that technology lands in like a particularly useful place. But it's obviously landed in a really fun consumer way that people are willing to spend money on, and they get value. They get value out of it. So no, those things are really cool. I recently saw somebody started using Stable Diffusion as a CAPTCHA on a website, which was I was like, yeah, it's very smart. So I think there are business applications for those things too. That whole like what you're talking about, Stable Diffusion and Whisper, like those are all multimodal. It's like we originally like machine learning was like looking at transformers and thinking about them as text because that's where they were amazing. Then slowly people started applying the models to other things. Now that worked a little bit. Now people are like trying out different neural net strategies on different things. Like the Stable Diffusion is a different architecture, but it's very good at taking in text and then creating an image, or Whisper taking in audio and then creating text. I think one day all of these modalities will be mapped by the same model. And one day we'll be able to give the model like whatever modality we want and get out whatever modality we want. And that's very exciting.
Absolutely. One thing that's required in this whole is massive compute. So I think you're partnering with Google Cloud. I mean, is there anything you can share about why Google and like how it may differ or not from like other cloud offerings to run your tech on?
Yeah, so these things require a whole bunch of compute. And the reason they require a whole bunch of compute is that when we talk about the neural networks have many, many billions of parameters. A parameter is just a number. So when people talk about like this neural network has a million parameters, what they mean is it has a million numbers that I needed to train. The state of the art transformers for language now have many, many billions of parameters and more. So it's a huge amount of numbers you need to train. And the way you train that is by showing them examples of what you want it to do, and then changing the numbers a little bit so that you get better at that task. You need huge amounts of really large computers in order to store all these numbers. You need really large computers in order to do the math required to figure out how to change the numbers to make it better at the task you're given it. You need huge amounts of memory just to store all the data that you're going to show it. The end result is you need really, really massive supercomputers to do this in any reasonable amount of time. So we're partnered with Google. We work on Google Cloud, and we use TPUs. TPUs are a particular specialized type of hardware. Just as a GPU is a graphics processing unit, a TPU is a tensor processing unit, and so it's a chip that's specifically designed. Tensor is just the name of a matrix with more than 2 dimensions, and we use that when training neural networks. So yeah, we use this particular type of computer, and it's particularly good at this task, and we get that from Google.
So one thing is crunching the numbers on computers. Another one is crunching the numbers in your brain. So you probably also need to hire a lot of engineers now, very specialized roles in this field. And AI is like super hot, while the rest of the economy is taking a little bit of a breather. AI is super hot. So how do you find it to hire and retain this type of super specialized talent?
I mean, we were always looking for great people. We've built a really incredible team. In the past year, we've hired some people who are like really phenomenal. So it hasn't been super challenging.
That's a good sign.
Yeah, to flex for a second. And yeah, I mean, sometimes I think about why that has been the case. One of the reasons I think is that what we're working on is very exciting and fun. It's a cool thing to work on. And so we've been really, really lucky to have like really like when I step back and look at our team, like it's really, really an amazing group of people. And so we try to make sure it's a good place to work. We try to make sure they're working on fun stuff. And in that way, keep them around.
Are you guys mostly remote, or do you have an office where people kind of come in?
We have a few offices. We like offices. I find that people enjoy going to them. So we're remote friendly. We have some people who are spread around the world. We have some people who live down the street from the office but never come in. And then we have some people who live far away but still like to come in every day. It's really all over the place. But we open up offices when there's a large enough group of people in any city. That means now we have an office in Toronto, which is our headquarters, one in Palo Alto, and we've recently opened one in London.
Got it. Maybe without giving away any secret sauce, of course, but like is there anything on the product roadmap you can share for the next 12, 18 months? Anything that you can kind of pre-announce or anything that you can share?
I think some of the things we're working on now are very cool and very relevant to you guys, in particular in the multilingual space. So if there's people who are listening who are excited about trying to map one language to another language, like stay tuned to Cohere.
That's a good teaser. So, hey, Nick, really appreciate you doing this. Thanks so much.
Cool. Thank you. Yeah, I really enjoyed the conversation.